Okay, good morning. Today we are doing Unit 2c, which is average rate of change. Now I need you to recall that your slope is also the rate of change. Okay, so we're not really learning something new here. It's just presented using a different word. So the key is that you understand every time that you hear rate of change is the same thing as finding your slope. So instead of them saying, find the slope, they're going to say, what is the average rate of change? Or what is the rate of change? It means the same thing. So when they say rate of change, you got to think about these formulas, okay? M, which is the variable that we use for slope. We can find rise over run, and this is if they give you a graph. You can use the change in y over the change in x if they give you a table. And please remember that the change means that you're subtracting x and you're subtracting y. That's all it means. And if they give me 2 points, 2 ordered pairs, then I can use this formula. And this will probably be one of 2 of the most popular ways you're going to find your rate of change here. Okay, you either are going to use 2 points, or whenever they give you a graph, you're going to use rise over run. Okay, because we can even use this formula when we're given a table, because a table gives you plenty of ordered pairs, so that means you can subtract the y's on the top, subtract the x's on the bottom. Alright, let's recall that a positive slope means that y is increasing as the x value, which is time in these examples, is increasing. So when everything's increasing, you have a positive slope. Alright, when the y value decreases over time, and remember time is representing x here, so time is increasing but the y values decrease, that means that we're going down. Okay, if you have a constant slope, that means we have a horizontal line, and remember that equation looks like this: y equals a number, and that number is wherever this line hits the y-axis. If you have an undefined slope, that is when your line goes up and down, and that type of line will start with the variable x and it will equal a number. Okay, so we have positive, negative, 0, or undefined. Okay, these are all the possible slopes that we can find whenever we have a line as our function. Alright, so over here we need to find the slope of this line, and we know that we get to pick 2 points, so I'm going to choose this point and this point. So for graphs, we use the formula rise over run. So I just need to figure out how many spaces I have to go up or down, and how many spaces I have to move side to side. Rise goes up or down. Alright, so to get from my lower point to my higher point, I have to move up 1. To move side to side, I have to move over 2 units. We just jumped 1, 2. So since I went to the left, that means 2 is negative. And since we went up, that means 1 is positive. Now we just put the numbers over here so that we can create our slope. So we rose 1 and we ran negative 2. And it's always negative if you're moving to the left. It's positive when you move to the right. Okay? That's it. I have just found the rate of change of this line. And the rate of change will be the same no matter what 2 points you pick. Notice if I went from this dot to this dot, I still have to go up 1 and over 2 in a negative direction. So whenever you have a linear function, the slope is constant. It will always be the same no matter what 2 points you pick on that graph. If your slope is not constant, then you do not have a line. Okay? Now, for my table over here, I'm going to switch up my formulas. This time, I'm going to use the slope formula. So I'm going to subtract the two y values on the top, and I'm going to subtract the two x values at the bottom. Okay? So we get to pick any 2 points that we want to. Please realize that each x is paired with a y right next to it. So these are the points that I'm picking from. You get to choose any 2 points that you want to choose. They just have to come from this table, okay? And they have to be directly across from each other. So I'm going to choose, I'll choose the first 2 points to make it nice and easy. So -5 and 7, because those two are paired together, and -3 and 4. Now I just need to label my point. So each point has an x as the first value and a y as the second value. So I'll label these. Since this is my first point, they're going to get little 1s. And since this is my second point, these get little 2s. It is very important that you give each point an x and a y value. You cannot give the first point x's and the second one y's. That would be incorrect, okay? Now let's plug into our formula. So what did we label y little 2? The 4. So we have 4 minus, what did we label y1? 7. Over, what did we label x2? -3. Minus, what did we label x1? Oh, a -5. Now this is important, okay? Because we already have a subtraction sign here. You cannot not use this negative sign as your 5's negative sign. If your 5 is negative, he has to have his own negative sign, and that makes it look like this, okay? Now we know that every time we see double negatives, they turn, both of them together, turn into one big plus sign. And it takes both of the negatives to do that. Now we're ready to subtract. So we have 4 minus 7, which you can do keep, change, okay? And we would get -3. On the bottom, we subtract these two numbers because the signs are different. That's why we're subtracting. 5 minus 3 gives me 2. So this is the slope, or the rate of change. Same thing. Now I could have chosen any 2 pairs of points and we still should have gotten -3 over 2. So let me pick another one just to prove the point. So it does, so that you guys clearly understand, it doesn't matter what 2 points you pick. I'm going to pick the last 2 points this time. So I have 1 and -2 and 3 and -5. So I go through and I label x and y, x and y. These will get 1s, these will get 2s. Okay? And then I set up my equation and subtract the numbers. So I will have y2 -5 minus y1 -2. Remember, he has to get his own negative sign. Alright. And then x2, which is 3, minus x1, which is 1. So double negatives change to one big plus sign or 2 positives, and we're ready. So -5 plus +2 gives me a -3. And 3 minus 1 on the bottom gives me a 2. So we notice we have the same rate of change, okay? Now, if you ever do this and these 2 numbers do not turn out to be the same, then this table right here would not be a linear function. Excuse my circle, okay? But that is the test that you have to do in order to determine if this table is a linear function. We must have the same slopes, the same rate of change, or it's not a function, okay? So we have proven that this is a linear function. We're done with that part. All right, so let's go down to our second table. I'm going to put the formula up here. y2 minus y1 over x2 minus x1. And we're going to pick any 2 points. I'm going to pick the first 2 simply because they are the smallest ones. Okay. And so this will be x and y, x and y. These will be the 1s because they are the first point. These will be the 2s because they are the second point. All right, now I'm ready for my formula. What 2 numbers am I subtracting on the top? -9 minus -7. Notice we're subtracting the y's, and these are the y values. So we start with y2, which is -9, minus y1, which is -7. Now we will subtract the x's, but we have to pick the second x first because that is what the formula calls for. So -10 minus the first x, which is -5. Now, all these double negatives we need to change. That becomes one big plus sign. This becomes one big plus sign. Now we're ready to subtract. So -9 plus 7, I know it says plus, but since the signs are different, we subtract the numbers. When in doubt, punch it out. Put it in your calculator. -9 plus 7, we get -2. On the bottom, we have -10 plus 5. Signs are different, so we subtract. And how many of y'all think we're done? Nope, we are not done. And the reason why we're not done is because I see a negative on the top and a negative on the bottom. And what happens when you have 2 negatives? Correct. 2 negatives make a positive. So this rate of change, or this slope, is a positive 2/5. You must simplify your answer. And whenever you have double negatives, you have a negative for your top number and the bottom number, it automatically becomes a positive. Notice there is no negative on the top or the bottom. 2 negatives make a positive. All right, our last example over here, we're finding the rate of change. They have already picked our 2 points, which are actually our x-intercept and our y-intercept from our first lesson, okay? Since this is a graph, we're just going to do rise over run. So I'm going to draw the direction I'm going. I'm going up first, and then I'm going to go over. All right, now moving up is a positive direction, and moving to the right is a positive direction. So both of these numbers are going to be positive. Now I just have to count them out. So we count as we move. 1, 2, 3, 4. So that is a positive 4. And remember that number goes on the top because that is my rise number. And then run will go on the bottom. So we have to run over 1, 2 spaces. Okay? Once again, we have to simplify. 4/2 or 4 divided by 2 gives me 2. So this is my rate of change, or my slope. All right, so notice all linear functions have a constant rate of change. And remember, constant just means that it is the same. If it's not the same, it is not a linear function. Okay, So that leads me to the second page of my notes. So right here is a rate of change. Is a rate that describes how one quantity changes, which on our example is y, as another quantity changes, which is x. Okay, so sometimes they ask you to find the rate of change, but they give you a certain interval. And the way that you know that they're giving you an interval is they're going to use braces, and they're going to put two numbers inside the braces, okay? So let's say I give you the numbers 1 and 4, but instead of them being inside of parentheses, they put them inside of braces, okay? This is the most important part right here. The fact that they put the numbers in braces means that they are giving you your first x value and your second x value. Now we know that we cannot find the slope unless we have some y's in here, because when we looked at all of our formulas, the rise is a y, this says the change in y, and this right here means that we're subtracting two y values, okay? So we have to have some y's. We can't just find our rate of change or our slope with just x values. So what you're going to do first is you're going to create two ordered pairs based off of the numbers that they gave you inside of the braces. So that means we have to separate these values, because ordered pairs only have an x as the first value. So our first x value will be 1, and our second x value will be 4. Now, we're going to get our y values from the graph, okay, or from the equation that they give you, okay? After you do that, we're going to find the rate of change, and we're going to use a slope formula in order to do it. Okay? So let's look at our examples. In this example, they gave me a graph. So they want me to find the rate of change, which is the slope, over the interval where the first x value is -4 and the second x value is -2. I cannot stress this enough. These values, when they put them inside of these braces, are x's. So I'm going to write my 2 points, and I'm going to put the first x value in the first point and the second x value in the second point. Alright? Now, where in the world do you think I'm going to get my y values from? The graph. That is the whole point for this graph over here. This is where we get our y values from. So if you remember the first warm-up that we did back from Thanksgiving, I gave you an x value and you had to tell me what the y value was. So we're going to go to where the x's, remember the x's go side to side. You're going to look at where the x is -4. Well, right here is where x is -4. But I don't see my line right here. So once I go to -4, I have to go down to my line. Here's the line. What is the y value at this dot? -2. So that is my y value where x is -2. See, x is -4 and the y value is -2. Now let's go to where x is -2. So x is -2 right here, but that's not on my line. So I have to go up to the point, this little zigzag line. Here's the point, and what is the y value here? 1. Okay? So that is the only reason why they gave me that graph. Okay? Once you get your your 2 points, we're just going to plug into the formula that we've been using on the other side. So y2 minus y1, x2 minus x1. We already know these are the first x and the second x. So this will be the first y and this will be the second y. And now we're ready to plug into our formula. So we subtract y2, which in this example is 1, minus y2, which is negative 2. Remember, he gets his own negative sign. And then we have x2, which is negative 2, minus x1, which is negative 4. So once again, I see the double negative, so I change both of the negatives into one big plus sign. Okay, and then we add or subtract. So since both of these numbers are positive, I just add and I get a positive 3. These are two different signs. The 4 is positive and the 2 is negative, so we subtract them and we get a positive 2 because we take the sign from the bigger number and 4 is the bigger number. So we have just found the rate of change. So the rate of change over the interval from negative 4 to negative 2 is 3 over 2. Now notice that this graph right here is not a line. Okay, while it does consist of several little lines, it is not one continuous line. Okay, so that means the rate of change can change in this line, and we're going to see that it's going to do that. Okay, let's write our new points down here. So we're finding the rate of change from where x1, the first x, is negative 2, and the second x is negative 1. So I'm going to write my 2 points again. Please make sure that you're paying attention because this is too easy to miss. Okay? Now we're going to go to where x, the first x, is negative 2. And the second x is negative 1. So please remember, when they give you two numbers inside of braces, it has to be braces. Then they're giving you two x values. Now let's go to our chart so we can get our y values. So the y comes from the graph. So let's go to first where x is negative 2. X is negative 2 right here. But we have to go up to our dot. And what is the y value? 1. Okay. Now let's go to where x is negative 1. So x is negative 1 right here, and I'm at the dot. So what is the y value right here? 0, because it's on the axis. Okay, so if we trace over, right here is 0, and that's where that dot is. Alright, so now we're ready to subtract using the slope formula. y2 minus y1 over x2 minus x1. So we're going to go ahead and label the y's because we already labeled the x's. So that's y1 and this is y2. So y2 is 0 minus y1, which is 1, over x2, which is negative 1, minus x1, which is negative 2. Alright, and then we just subtract. So 0 minus 1 is negative 1. When in doubt, punch it out. Okay? And for the bottom, we got to change double negatives before we add or subtract. So now we see the signs are different. So that makes me subtract. And we take the sign from the bigger number, which is a positive 2. Once again, if you're having problems with your sign rules, do not do this in your head. Please put it in the calculator, because this is too easy to be missing, okay? So now we got to simplify. Negative 1 divided by 1 equals 1. So the rate of change equals 1. ROC, rate of change. Okay? Now, if you would, Miss Hall, please pause the video to let them try number 2 on their own so that we can make sure that they understand. Okay, so 0 is the first x and 2 is the second x for your first problem. For the second one, 2 is your first x and 4 is your second x. Okay, you can pause the video. Alright, I hope everybody actually tried to do this on their own so that we can make sure that everybody is able to get the correct answer. Okay, so I'm going to write my 2 points first. Remember, the first number is the first x, so it's going to go first in my point. The second number is the second x. They always go first in your point because they are the x values. And we find the y values from my chart. So let's go to where x is 0. X is 0 right here. I go up to my dot, and the y value is 2. Oh, let me change my color. Alright, so where x is 0, this is where x is 0. I have to go up to my dot. Here's the dot, and the y value of that dot is at 2. Alright, now let's go to where x is 2. X is 2 right here, but I have to go to the zigzag line, which is right there. And what's the y value at this point? -2. Alright, so we are ready to find the slope. So y2 minus y1 over x2 minus x1. Okay, so we subtract what two numbers on the top? -2 minus 2. Very good. What two numbers are we subtracting on the bottom? 2 minus 0. Alright, so -2 minus 2 is the same thing as -4. When in doubt, punch it out. Okay, on the bottom, 2 minus 0 is 2, and we need to simplify. So -4 divided by 2 is -2. So that is my rate of change. Now let me show you another way that you could have done this in your graph. So you notice how I circled the point where x was 0. This is the point where x was 0 because x is 0 here, and that's the point on the line. Then I can circle the point where x is 2. Well, x is 2 here, but I have to go down to get to the zigzag line here. So since we're dealing with a graph, I can simply do rise over run. Okay? So how many spaces do I have to rise to get from this dot to this dot? I have to rise 1, 2, 3, and 4. And since we went up, that is a positive 4. Okay? Then I have to run to the left, which we know is a negative direction. Okay? How many do we have to run? 1, 2. Well, look, that's the same slope that we had here. Remember, I told you the negative could be on the top or the bottom, but we still have to simplify it. So we get -2. Same rate of change. So you can do it using rise over run, or you can use your 2 points. Okay? If you have problems remembering which way is negative, then I would strongly suggest that you use the 2 points. Okay? Now let's check over 2b so we can move to our last part of our lesson for today. So I'm going to write my points. This one is 2, this one is 4. This is x1, that's x2. This will be y1, and this will be y2. Alright, so let me clear this off since I have really drawn all over my graph here. Alright. Alright, so let's go to where x is 2. X is 2 here. This is my point. Now, what is the y value at this point? -2. All right, now let's go to where x is 4 because that's the value here. X is 4 here, but we have to go up to the red line. So there's my other dot. So if you're going to do it graphically, this is what you're looking at. And I need to get my y value for this dot, which is 1. So I'll show you both ways again because some people will like to use the formula and some people will like to use the graph. It doesn't matter. We're all going to get the same answer. So one way is not any better than the other way. Alright, so y2 minus y1 over x2 minus x1. Okay, so 1 minus negative 2, y2, which is 1, minus y1, which is negative 2, all over x2, which is 4, minus x1, which is 2. Both of the double negatives turn into one big plus sign. So I get 3 over 2. And that is my rate of change. Alright, now let's look over here. They had to go up 1, 2, 3. Since they went up, that is a positive 3. And remember over here, we're using rise over run. Then they ran 1, 2. So 3 over 2. Same slope, same rate of change. It is the same. Now notice when you compare this rate of change to what we had in A, they are not the same number. So that tells you this is not one continuous line, okay? Because they would all have to have the same rate of change. All right? So on to our last section. Almost done. Stick with me. This whole time I've been telling you that in order for something to be a linear function, it must have the same rate of change. If the slope is not the same for all points, it is not a linear function. So in this example, they're going to ask me to find a specific rate of change. Okay, then we're going to determine whether this whole chart over here is going to be a linear function or not. So notice they didn't give you a visual. You can't just look at it and see, does it make a line? We're going to have to use what we learned. Okay, we have 2 problems left. Stick with me. All right, A says find the rate of change from day 1 to day 2. So here's our days, day 1 to day 2. Okay, but in order for us to find the rate of change, we're going to be using a point. We need the x value. Remember, f of x is the same thing as y. Okay, so we're going to use this value and this value. So these are my 2 points. Okay, 119 and 230. This is how your problems look on your CDA. You know they like to tell these wonderful stories, okay? So here we go. Let's find the rate of change. So the rate of change from 1 to 19 and from 2 to 30. So I label x and y, x and y. These get 1s because they're the first point. These get 2s because they're the second point. So we subtract what 2 numbers on the top? 30 minus 19. Very good. And what 2 numbers will we be subtracting on the bottom? 2 minus 1. All right. So what do we get on the top? 11 over 1, which is the same thing as 11. Okay. So using the variables, remember y's went on the top. So 11 is the amount of bacteria per day. And I don't say per 2 days, even though we accounted for 2 days, because remember, we divided by the change in the x's. So this number 11 represents how much bacteria. This is supposed to represent the amount of bacteria from day 1 to day 2. Now, in order for this to be a linear function, the rate of change for our second example should be the same as our first example. If we do not get 11 for our second example, then we would say this example is not a linear function. If we do get 11, we can say that it's a linear function because linear functions have the same slope or rate of change. All right? So let's find the rate of change from day 2 to day 5. So day 2 has the point of 230. And what is the point for day 5? 5 and 121. Now, for this one, let's label our points. So X and Y, X and Y. These get 1s because they're the first point. These get 2s because they're the second point. What two numbers are we subtracting on the top? 121 minus 30. Very good. And what two numbers are we subtracting on the bottom? 5 minus 2. Alright, so 121 minus 30 gives me 91. Okay, what do we get on the bottom? 3. And let's divide 91 by 3. Alright, so we do not want a decimal, so remember you're going to hit math and hit enter 2 times. Okay, well, we get back this same fraction. So, the first rate of change between the first 2 days was 11 bacteria per day. This one down here, this rate of change says that we have 91 bacteria per 3 days because the 3 is on the bottom, and remember days is for x's. Days represent x's. Bacteria represent y. So this is 91 bacteria for every 3 days. So when I ask you, is this a linear function, you have to say no, because the rate of change is not the same. So you have one of these problems on your CDA where they ask you to pick all of the functions that would be linear. So whenever you see a table, you know you have to do the rate of change. All has to be the same. Now, if they give you a graph, that's going to be obvious. If it doesn't look like a line, it's not a linear function. It has to be a straight line. Alright, so you can pause the video and let them try number 4. Find the average rate of change. Alright, so once again, I hope that you guys actually did this yourselves so that you can make sure that you understood how to do this. So in 2008, about 66 million U.S. households had both landline phones and cell phones. Let's find the rate of change from 2008 to 2011. So we're not going to use all these points, okay? We're only going to use the ones that they gave us. They said use the year 2008 and 2011. So these are the 2 points that we're using. Okay, so remember X is represented by years, and Y, which is f of x, is the same thing. Okay, they are represented by households in millions. So they didn't write 66 million, but we know that represents millions of households. So let's find our rate of change. So x1, y1, x2, y2. The formula: subtract the y's on the top, subtract the x's on the bottom. So 51 minus 66 over 2011 minus 2008. All right, so 66 minus 51 gives me negative, hold on a minute. Okay, negative 15, which makes sense because we're taking a bigger number from a smaller number. So we did this correctly. On the bottom, we subtract 2011 minus 2008, and we get 3. Which means that our total rate of change here is negative 5. Okay? So what does the negative 5 mean? It means the rate of change between landlines and cell phones from 2008 to 2011 was 5 million households per year. Okay, so there was a decrease in the amount of households that had both landline phones and cell phones. And we say decrease because this right here was negative. So this is the amount that it decreased each year. Well, let's check and see if this is a linear function. If this is the case, then it should have went down by 5 each year. So if we take 66 and subtract 61, do we get 5? Yes, we do. Now let's check these two. Okay, 61 minus 56 gives me 5 again. So that's good. And then let's subtract here. So 56 minus 51 also equals 5. Okay, so this supports the notion that we have a linear function. Yes, it is linear because the rate of change is the same every year. And that rate of change was a decrease in 5 million households per year. Okay? That concludes rate of change, which I know most of this was a review. Thank you so much for paying attention. You guys have an awesome weekend for my evening classes. And for Monday, we're kicking this week off strong. We have 2 more lessons, and then you're done learning new stuff before Christmas, okay? We'll be getting ready for our CDA. Thank you so much. Please be good for Miss Hall. Otherwise, I will be calling parents, all right? You guys have a good day.